Okay, we're on problem number 17, and 17 is using a limit definition. We want to prove this limit. X goes to 1, finite number, function x squared plus 2x equals 3, finite number. Classic epsilon delta definition. Let's go to the whiteboard, and let's see if we can do 17. All right, so number 17 at the whiteboard. Let's take a look. 17, and 17 reads the limit as x goes to 1. The function is x squared plus 2x, and this is going to be equal to 3. All right, and it stands to reason. We plug in 1. Limit laws, by the way, you get 1 plus 2, which is 3. Okay, this is epsilon delta definition, and let's go to town on it. What do we get over here? Given. We're given an epsilon, and that epsilon is greater than 0. What are we going to do now? We want to choose. And again, I can't look at this and know what it is, but we want to choose a delta, and that's going to be in terms of epsilon. So we don't know what it is yet, but what we write down is we want to suppose now. S-U-P-P-O-S-E. We can suppose the difference between x and 1 is less than some delta. And the bottom line is x is not equal to 1, so the absolute value of x minus 1 is not equal to 0. So this is going to be a positive number now. All right? What do we want to check now? And this is the part where most work comes in play. And it's going to be the function x squared plus 2x minus 3. And I got to manipulate this thing, because one thing I'm looking for is I want to look for a factor of x minus 1. Well, I kind of see that like almost immediately. And this is x and x. It factors nicely. So 3 and 1. And it looks like minus 1 plus 3. So this is equal to the absolute value of x minus 1 times the absolute value of x plus 3. Right? This will be less than delta absolute value of x plus 3. And this is where I got troubles. And so what are the troubles going to be? I got to get that x plus 3, the absolute value of it. So what I'm going to do is I'm going to say minimum. I need to select some number for delta. And I'm going to say 1. There's going to be another thing over here. It has to do with epsilon. But let's see if we can figure this out. So what do we got? We chose, the minimum. I got 1 so far. So the absolute value of x minus 1. Let's see, greater than 0, less than 1. I'm going to remove the absolute value symbol. That means that's between these two numbers here. What do we do now? I got to get the plus 3. So I have to add, I guess, 4 to all the sides, right? What do you get? 3. You get x plus 3, and you get 5. Whoops, I didn't mean to do that. I don't know what happened there. Actually, I know what happens. I have something on my mind, and I have absolute values on my mind at this point. This is 5. All right, what does this mean? The absolute value of x plus 3 is less than 5. So I have something now. And what do I have? I know the absolute value of x plus 3 is going to be less than 5. So let me go back over here, and let's write this down now. And I got to be careful about it. And I got delta, the absolute value of x plus 3 will be less than delta times 5. All right? This is going to be less than or equal to epsilon now. So what's this going to be over here? Whoops, not the 5. I know the 5 is always 5, right? What's the epsilon going to be? Well, the epsilon would be, the delta would be epsilon over 5. That's what we're going to choose. Put this over here. And we are now done. We're done with the problem. This is a QED now. And again, just to remind you, these problems are coming from black pen, red pen. He puts a little square box there and shades it in. I'm just putting QED down there. Look for variance in the way people do work, by the way. I do like the way he sets these up, by the way. I like this give and choose, suppose, check. All right? It's also orderly. It also, if a teacher follows this and the students can follow this, it would be easier for the teacher to look at and grade it, right? Because sometimes these things are all over the place when a teacher looks at it. This is why a lot of teachers don't like to assign difficult problems, by the way, because grading it's extremely difficult. Thank you.